I still have a bit more to tell you. Do you remember the formula for area of trapezium? Okay, what is it? Perpendicular height, right? Okay, what if I give you this diagram? So x and y, a and b over here. The coordinates for b will be 3 and 10. Coordinates for a will be 1 and 7. Okay, do you know how to find the area of this shaded part?
Yes.
What is the area of shaded part? Equals to half times 7 plus 10 times y3. Okay, because here we've got 2. This is 10 and this is 7. Okay? So this is how we find the area of a parallelogram. Now, if I have a triangle like this with the coordinates x1, y1 is A, x1, y1, B, x2, y2, and C, x3, y3. If I have a triangle like this, are you able to find the area of this triangle?
Yes.
How? Draw dotted lines down. Okay, let's drop perpendicular lines down. Okay, so what this means is that this is x2, this is x1, and this is x3. Now, how do we find the area of this triangle? Using what we just did earlier on, area of trapezium.
Because when you x1, right, you like separate both, right? Then they are actually two trapeziums.
Where two trapezium?
Between x2, x1, and x1, x3.
x2, x1.
x1, x3. There's two trapeziums.
The A to x1,
Yeah, or x2 to x3.
C to x3.
Yeah.
Wait, are you talking about this one?
Yes, yes.
This trapezium?
Yeah.
That's what it
Okay, so this is a trapezium, right?
Yeah.
Can you find the area of this green trapezium?
Yes.
Can you find the area of this trapezium also?
Yes.
Or if you can find these two trapeziums areas, we can add them up, right?
Yes.
Then after that, if I subtract this, wouldn't I get area of triangle? So it can be done, right? Let's try. Yeah, it's quite tedious. It's quite tedious, but let's just try it. And we see whether we can get something interesting or not. So, for this one, area equals to half times the sum of parallel sides. What is the sum of parallel sides? Which one plus which one? y1 plus y3. Half times sum of parallel sides times x what?
x3 minus x1.
Okay, so this is the area of the red side, isn't it? Now let's have the area of the blue one. Okay, so the area, sorry, very messy. Half times y2 plus y1 times. Okay, now that we have these two, we are going to add them up, right? Then I want to subtract something else. What do I subtract?
B to x2.
Let's have this green color part. So area equals to half times y2 plus y3 x3 minus x2. Okay, so area of triangle. Area of triangle is red plus blue minus green. Am I right? Red plus blue minus green. Okay, okay. So area of triangle equals to half y1 plus y3 x3 minus x1. This is red plus blue y2 plus y1, x1 minus x2, minus green, half y2 plus y3, x3 minus x2. Complicated? Factorize. What can we factorize out? Half. Okay, now big bracket. I unfortunately need to expand. Never mind, 5 minutes can finish one. Let's expand. Rainbow. y1 x3 plus, minus. y1 x3 minus y1 x1 plus y3 x3 minus y3 x1. Okay. Plus y2 x1 y2 x1 minus y2 x2 plus y1 x1 minus y1 x2. Wait, not yet. Then there's still a minus this whole chunk, right? Okay, minus. Minus, but I scared that I'll forget to put in the, I scared that I'll forget about the negative sign. So I put a bracket here first. y2 x3 minus y2 x2 plus y3 x3 minus y3 x2. Correct? Now it's time to see what we can subtract off. Do you see anything that can be subtracted off?
y1 x3.
Where they are? Y,
First one and the fourth one.
y1 x3.
Yeah, and then the y3 x1.
Where got y1 x3? y1 x3 not the same as y3 x1, no. y1 x1, okay, there's a negative y1 x1 here. Where else? Oh, this one. So they can cancel, right? Okay, cancel. Any more? y3 x3, this positive, and where? Oh, this one. But this one positive y3 x3. Oh, but there's a negative sign. Okay, yes, you are right. Can cancel. Oh yes, you saw the y2 x2 also. This negative, then this is negative, negative, positive, right? So we can cancel. So what are we left with? Half y1 x3 minus y3 x1 plus y2 x1 minus y1 x2 minus y2 x3 minus y3 x2. Plus. Oh yeah, I forgot. This one plus. Correct? This is the formula for finding area of a triangle. You want to memorize it? Don't want to memorize it. But this is how it is derived. We can extend this to a parallelogram, rhombus, any shape as long as they are made out of straight edges. So something like this, as long as I give you all the coordinates, you will be able to use the same method to find area. Okay? But it is very tedious. It is very difficult to memorize this also. So there is an easier way. It is known as the shoelace method. All look at our shoes. Shoelace. Look at our shoelace. You see crisscross? Oh, the shoelace got crisscross, right? The method looks very much like it. Okay? So for our triangle, earlier on we had x1, y1, x2, y2, x3, y3. If you don't understand what I just derived just now, you need to pay attention to this part. 2.5 minutes, please wake your friends up. To find this area, all you need to do is to write down area equals to half, you draw a vertical line. Okay? Just draw a vertical line, I'll explain what it means. You get to choose any point you like. A, B, or C. Okay, choose. What do you want? A. Okay, let's start with point A. So right now, x1, y1. You've never seen this before, but it's okay. Now I'm telling you that it looks like this. This is the presentation for the shoelace method. So x1, y1. Now I need the coordinates of another point. Which point do you want me to choose? x2, y2 or x3, y3? Does it matter? Yes, it matters. You must go anti-clockwise. Okay? You get to experiment what happens if I go clockwise. You get to try it for yourself. But I'm not telling you, you must go anti-clockwise. So what must the next point be? X2, Y2. Then the next point must be X3, Y3. Do I stop here? No, you must complete it by going back to your original point. What's the original point? X1, Y1. So these are the 2 points. You must go anti-clockwise. You must end where you started. Okay, which is what I've shown so far. This is our first step. Okay, so far? So you close by drawing another vertical line. I shall not tell you what the vertical line means, okay? It doesn't matter to you right now. What? No, it is not modulus.